So welcome to this session whereby we'll be proceeding on with the topic calculus. As I had mentioned yesterday, calculus is divided into two, or rather in the previous work, calculus is divided into two parts. And in this case, or during this session, I am going to take you through the second area of calculus, which is called integration. So that is the other topic. Integration. So this is the second topic. And from the onset, I want to mention that integration is basically the reverse process of differentiation. So in differentiation, we were multiplying. In this case, we will divide. In integration, we were subtracting. In this case, we are going to add. So differentiation, or integration rather, is the reverse process of differentiation. So you will need to recall how we were differentiating for us to be able to integrate. So let us take, for example, so given that dy over dx is equals to 2x, so this is basically the gradient function of a curve. Dy over dx is the gradient function. Now you have the gradient function. You are supposed to find the equation of the curve. So find the equation of the curve. So given that dy over dx, so basically this is a gradient function of the curve. If you have the gradient function, then you need to recall that for you to get a gradient function, or what we also call the derivative or the derived function, you need to know that we got this by differentiating. So to get the equation of the curve, we do the reverse process. We integrate, and that process of the reverse process is what we are calling integration. So this topic, we need to figure out how then do we integrate, and I have just said that integration is the reverse process of differentiation. So let's see. So to indicate you're integrating, you must use an elongated S, written that way, to show that you are integrating 2x with respect to x. This means you're saying integrate 2x with respect to x. Integrate 2x dx with respect to x. And when you integrate this, you should get the equation of the curve. dy over dx means that is the gradient function. So when you integrate that, you should now get the equation of the curve as y is equals to, because it's dy over dx, so you're going to have y is equals to, integrate this 2x. So I have said if you have 2x, this is to power 1. So for us to get 2x in differentiating, to get this, we subtracted 1 here. So in this case, we will do the reverse. We add 1. So we are reversing the process. We add 1. In this case, we took the power 1 times the coefficient, so 1 times 2. In this case, we, after adding 1, we divide by the result. So 1 plus 1 is 2. And notice that in this case, we have 0. So because it was only 2x. Now, what did we say about getting 0 when you differentiate? We say that when you differentiate a constant, you get the answer as 0. So in this case, that means there is a constant here. But we don't know whether it's 1, 2, 3, 7, 8, 9, 20, 30, 50, etc. We do not know what that exactly is. So since we don't know, we just use a constant c. So plus c. And in that case, our equation should be y is equals to, by 2, and so we have x squared plus c, constant. That way, you have reversed the process. Let me pick another one. So another example, dy over dx is equals to 3x squared. So again, same process. So you integrate 3x squared with respect to x. So 3x power 2, so y is equals to 3x power 2 plus 1. So you add 1, then divide by the result, which is 3, then plus a constant, because when you differentiate a constant, you get 0. So we introduce that constant plus c. And in that case, we have y is equals to x cubed plus c. We can go on and on, but let us see in a case whereby we have quite a number of polynomials. So we are told dy over dx is equals to 5x cubed minus 2x plus 4. So again, you must indicate you are to get the equation of the curve, integrate 5x cubed minus 2x plus 4 with respect to x. So initial step, we are going to have 5x power 3 plus 1 over the result, which is 4. That is y is equals to minus 2x, this is power 1, so 1 plus 1, so over 2 plus 4. So if this is a constant 4, that means its x was to power 0, such that x to power 0 is 1. We say in differentiation, any number to power 0 is 1. So x, it was to power 0, so we add 1, then divide by the result, and the result is 1, plus, since the last part is not there, so we are assuming that there was a constant which was differentiated to get 0, so plus a certain constant. That way, you can now say y is equals to 5 over 4x cubed minus x squared plus 4x plus c. And that is how you carry out the process of integration. That is how that is basically the reverse process of differentiation. Maybe you can look at one more example on how to integrate. Let me capture it here. So dy over dx, that is example number 4, is equals to x to power negative 1. So integrate x to power negative 1 with respect to x. That we have y is equals to x to power negative 1 plus 1 over the result negative 1 plus 1, that is going to give us a 0. Sorry, this should be negative 2. Let's solve the negative 2 so that we don't end up with a 0. So to power negative 2. So power negative 2. So negative 2 plus 1 is negative 1. Plus, remember, these are 0. That means there was a constant which was differentiated. So plus a constant c. So we have y is equal to, this is negative 2 plus 1 is negative 1. So we have x, or rather negative x to power negative 1 plus c. Because this is basically, instead of writing x over negative 1, that is the same as negative x to power negative 1 plus c. So that is basically what we need to understand in as far as integration is concerned. You need to figure out, you need to understand integration is the reverse process of differentiation, and that is it. So having done that, let us now proceed on to something else, whereby you are given the gradient function of a curve, then you are supposed to now find the actual equation. That means in this case, you are going to be given the point where the curve passes through. So in short, we will be required, or we should be able to get a value of C in this case. I want to use this example. You're told find the equation of a curve whose gradient function is dy over dx is equals to 2x plus 3 and passes through passes through 0, 1. So let's see what this exactly means. So I am given the equation of the gradient function of the curve and one of the points where the curve passes through. So let's see whether it is possible to get the equation of that curve. So having the gradient function, we should be in a position to get the equation of the curve. That is, we got this gradient function by differentiating the curve. So to get the curve, we integrate dy, that means integrate 2x plus 3 with respect to x, to imply that y is equals to 2x, this is to power 1, so 1, add 1 because you are integrating, then divide by the result, which is 2, plus 3. If this is 3, that means it's x was to power 0, so you're going to have x to power 0 plus 1 over the result, which is 1, plus a constant c. When you simplify that, we get y is equals to x squared plus 3x plus c. But we are told the curve passes through this point, so we cannot leave our answer as such, since we already have the values of x and y. X is equals to 0, y is equals to 1. So that should help us to get the value of c. So y is 1 is equals to 0 squared plus 3 into 0 plus c, because x is 0. So in that case, we are saying c is equals to 1. So having the value of c, we are simply saying y is equals to x squared plus 3x plus c, which is 1, plus 1. So you notice in that case now we have the value of c. We don't leave it as such. But instead, since we have one of the point where the curve passes through, then you need to replace the values of x and y to get the value of c, which is 1. And that is how you find the equation of a curve given a gradient function and one of the points where the curve passes through. We will now make progress, and so you can try this. I'll copy the question and the answer, then you will figure out how I got the answer. So number 3, find V in terms of H if dV over dH is equals to 3h squared plus 4 when and V is equals to 9 when H is equals to 1. So find V in terms of H if dV over dH, the derivative of V with respect to H is equals to 3h squared plus 4 when and V is equals to 9 when H is equals to 1. And the answer you should get is V is equals to h cubed plus 4h plus 1. So you will figure out, so do your sum, but make sure you get that answer. So solve this and get that answer. V is equals to h cubed plus 4h plus 1. That is the answer that you are expected to get. So in the next part, is definite and indefinite integrals. Definite and indefinite integrals. So starting with the definite, let us see what these really mean. Definite integrals. Definite integrals. Or rather indefinite. I think it's easier when we start with indefinite, because in that case we are only required to integrate that. So if I am given, we call it indefinite. If I am given integrate x squared plus 1 with respect to x. So when you integrate this, you should get the first part, x power 2, add 1, divided by the result, which is 3, plus 1 means it's x was to power 0, that is why we are left with 1. So add 1, divided by the result, which is 1, plus, we don't have any other value there, that means it was a constant, that is why when it was integrated or differentiated, the result was 0. So the constant c, and our indefinite integral will be x cubed over 3 plus x plus c. So you realize in this case, we cannot get a definite answer, such as 50, 20, 7. Instead, we have a polynomial, x cubed over 3 plus x plus c. This is an indefinite integral, indefinite. So when you just integrate, you just get that. You cannot even get the value of c. So that is an indefinite integral. Indefinite integral. Now what happens in the case of definite integrals? So So in definite integrals, we are going to get a specific answer. For example, I am told to integrate 2x squared plus 3 with respect to x, but in this case I am given the range from 2 to 6. So that means 2 is the lower limit, 6 is the upper limit. So this is what I had mentioned yesterday in a differentiation that I will demonstrate later how to apply that. So when we were talking about time, during the third second, during the fourth second, between t and is equals to 2 and t is equals to 5. That is what we were doing yesterday, and rather in the previous session. So in this case, I will show you how to apply that. So let's see, the first thing is to integrate. So integrate, we already been told to integrate, so we have 2x power 2 plus 1 divided by the result 3 plus 3, it is x power 0 plus 1, so over 1 plus a constant c. But notice what you are doing here, we now bring in the limits. So the lower limit 2, the upper limit 6. When you integrate that, when you simplify that, you should get 2 over 3x cubed plus 3x plus c for the limits 2, 6. Then from there we now replace. We have 2 over 3 into 6 cubed plus 3 into 6. The upper limit, you start with the upper limit, plus c, then close the brackets, subtract, so you minus the lower limit. 2 over 3, 2 cubed plus 3 into 2 plus c. So the first part here, we get 162 plus c minus the other part, we get 34 over 3 plus c. When you simplify this, when you open the brackets, we get 162 plus c, open the brackets, minus 34 over 3. I want you to see how c disappears or how c cancels out. Plus minus, you get minus c. So collect the like terms. We have 162 minus 34 over 3, which gives us 150 and 2 over 3. And the other one, c minus c is 0. So the answer is 0. 150 and 2 over 3. That is an example of a definite integral. That is an example of a definite integral. So in your case, I would want you to do this. I'll give you the question and then the answer. Then you go find out how you got that answer. So I want you to, let me erase this. You have 3x power 2 minus 4x. Remember, you're told to integrate that for the limits 2 to 3 plus 5 with respect to x. So the lower limit is 2, the upper limit is 3. So, and these are definite integral because you can replace 2, 3 to get a definite answer, and that answer should be 14. So the answer that you should get is 14. So solve that question and get that answer 14. You should get 14. If you don't get 14, then your answer is most likely not correct. The answer is most likely not correct. And now I want to proceed to another area of this topic called area under the curve. This is also very, very important, considering that we shall be using the same concept in our next area or next topic called area approximation. So if you understand this, the next area we will only be doing 2 concepts in calculating area. So I want to pay attention to, or rather proceed on to area under the curve, or under a curve. So area under a curve. So this is basically a development of what we've just done, what in definite and indefinite integrals, and it is definite integrals to be exact. So if you have such a curve, and I am told that this is 2, and this is 4. The equation of the curve y is equals to x cubed, yes, with x squared. So you can get the area under this curve using integration by integrate. So you integrate x squared with respect to x for the limits. So the lower limit is 2, the upper limit is 4. So to get that area, integrate. So we have x to the power 2 plus 1 over the result 3 plus a constant c. And in this case, the range, the lower limit we've been told is 2, the upper limit is 4. So it's as simple as getting the case of the definite integrals. So we have x cubed, write it here, x cubed plus c over 3 lower limit 2, upper limit 4. So the next assignment is to replace. So we have 4 cubed over 3 plus c minus lower limit 2 cubed over 3 plus c. And the first part gives us 64 over 3 plus c minus 2 over 3 is 8 over 3. So 8 over 3 plus, sorry, not plus, but when you put the brackets, this will be minus c. Again, c will cancel out. C minus c is 0. So we have 64 over 3 minus 8 over 3, which gives us the answer of 18 2 over 3. And so the area under that curve is 18 2 over 3. And you can, in case since we don't know it's centimeters or meters or kilometers, you just call it square units. Square units. We don't know whether it's meters, centimeters, kilometers, miles, etc. And that is how we get the area under. Excuse me. So under that curve. Under that curve. Let me focus on another example. Still area under a curve. So this is example number 2. Find the equation, the area bounded by the curve y is equals to x cubed minus 3x squared plus 2x and the lines x is equals to 1 and x is equals to 2. And that implies this is the lower limit, this is the upper limit. When you plot this curve, I will show you how to sketch a curve later. But when you plot that curve, if this is the x-axis, you should get such a curve, whereby this is 0, this is 1, this is 2. Notice that the question is not asking us to get the entire area. The question is asking that we only get the area bounded by the lines x is equals to 1 and x is equals to 2. So this is the area that we are focusing on. So the first step is to integrate that function. X cubed minus 3x squared plus 2x. Notice the limits should be from 1 to 2. The question is specific on the range. Where are you going to start and where is it supposed to end? So when you integrate that, you should get x at power 4 over 4 minus 3, not 3, but okay, let me x cubed plus x squared plus c. So when you integrate, that is what we should get. Lower limit is 1, the upper limit is 2. So after getting that, we now replace, which is going to give us upper limit. We have 2 to the power 4 over 4 minus 2 to the power 3 plus 2 to the power 2 plus c minus 1 to the power 4 lower limit over 4 minus 1 to the power 3 plus 1 to the power 2 plus c. So the first part, when you solve this, you will get 0 plus c minus this one will give us 1 over 4 plus c. So when we open the brackets, you're going to have 0 minus 1 over 4 plus c minus c. So c will be 0, so the answer is negative 1 over 4. Now, the answer being negative 1 over 4 means that you need to understand, and this is something which is obvious. If you are to get the area of a piece of land, or of a triangle, or a rectangle, or of any shape, you can never get the area being negative. But in this case, we have an area which is negative. The implication of this is that that area is below the x-axis. Below the x-axis. And as you can see from the sketch of the curve, this area from 1 to 2 is below the x-axis. So negative 1 over 4 means the area is below the x-axis. But in actual sense, the area is not negative 1 over 4, but it is 1 over 4. The negative is simply meant to indicate that the area is below the x-axis. So our answer should be positive 1 over 4 square units. Let us look at another example. We are told find, so this is number 3, find the area bounded by the curve y is equals to x squared plus 10x plus 9 and the lines x is equals to 4 and x is equals to 10. So let me start by sketching how that curve should look like. So when you sketch the curve, so although later we'll still do how to sketch a curve. So your curve should look as such, and we say that is where we have 10, we have 4 somewhere there. And the point where this curve meets the y-axis, the x-axis at this point is 9. So this is the area we are looking for. Because when you sketch this curve, that is what you're going to get. So we have from 4 to 10, and notice that at this point the curve meets the x-axis at this point. One thing that becomes outright here is that part of the curve is below the x-axis and part of it is above the x-axis. In our previous example, we have said that the area which is below the x-axis, the answer is always going to be a negative value, but you cannot leave the answer as a negative value. So you ignore the negative sign because area cannot be negative. Now in this case, that which is above the x-axis, the area is obviously going to be positive. Now, do we do straight from 4 to 10? You integrate from 4 to 10. That can be grossly, in fact not can be, but that is grossly incorrect, because you notice that part of the area is negative. So if you do them wholesome, part of the area will cancel out, will be eaten away, and in some cases you will get an answer of a 0. But you obviously know that area cannot be 0. So how do we eliminate that error? To eliminate that error, you calculate the area which is below the x-axis first. That is from 4 to 9, to get the area which is below the x-axis. And then from there, calculate the area which is above the x-axis. So you start from 9 to 10. What am I saying? I am simply saying that you integrate x squared plus 10x plus 9 with respect to x from 4 to 9 below the x-axis. Then the area you get, add to the area from 9 to 10, because that is the area above the x-axis. So you must do them separately. The area above the x-axis, the area below the x-axis. So from 4 to 9, when you integrate that, by now you should be able to know how to integrate. So when I integrate that, I get x cubed over 3 plus 10, sorry, not 10 but 5, x squared plus 9x plus c for the limits lower limit 4, upper limit 9, plus the other area which is above the x-axis, x cubed over 3 plus 5x squared plus 9x plus c, lower limit. So you start again from 9 to get the area above the x-axis to 10 above the x-axis. Now you should be able to solve this. Replace for 9. We have 9 cubed over 3 plus 5 into 9 squared plus 9 into 9 plus c minus lower limit 4 to the power 3 over 3 plus 5 into 3 squared plus 9 into 3, not 3 but 4, and into 4 plus c. That is the area below the x-axis. And the area you should get here is, the answer in this case is negative 58 and 1/3 when you solve that. But we know, we have just said that area cannot be negative. This simply indicates that the area is below the x-axis. So the answer we get here is negative 58 and 1 over 3. So what we do, you ignore the negative sign, and the area therefore below the x-axis is 58, 1 over 3. Below the x-axis. How about the area above the x-axis? We replace the same thing. So we have, remember we said add. So we add upper limit is 10 power 3 over 3 plus 5 into 10 squared plus 9 into 10 plus c minus lower limit 9 power 3 over 3 plus 5 into 9 squared plus 9 into 9 plus c. Close the brackets. So when you solve this, the area above the x-axis, we get an area of 4 and 1 over 3. That is the area above the x-axis. This is the area below the x-axis. This was negative, you drop the negative sign. So to get the total area now, we add the two. 58, 1 over 3, plus 4 and 1 over 3. And the total area under that curve is 62 and 2 over 3. Square units, 62, 2 over 3. So we add the two to get the total area. And that is how you get the area under that curve. So you need to understand that. So make sure you do them separately. The area below the x-axis, the area above the x-axis. For you to be able to get that area accurately, you must do them separately. That is extremely significant. Let me do one more example on the same. Getting the area under the curve. That is number 4. You're told to find the area enclosed by the curve y is equals to find the area enclosed by the curve y is equals to 9x minus x squared, and the line y is equals to x. So in most cases you will be given a diagram. So in this case I'll still give you the diagram. So this is how it looks like when you draw that. So I have the curve looks like that. This is the line y is equals to x. This is y is equals to 9x plus minus x squared. This is the line y is equals to x. So we are told to find the area bounded by this line and the curve. The curve and the line. So you have the curve here and the line is here. So the area is here. So you're looking for that area. You're looking for that area. So how do we get that area? How do we get that area? Because that is one of the most important things at that particular point. So one thing you need to remember, in trigonometry, I think we must have mentioned that in trigonometry 2 and in any other equation or curves, we said where the two curves intersect, then they are equal at that point, because we must be able to get the limits. It might be obvious that at this point the values are 0, 0. But how about at this point? Because for us to integrate, or to get that exact value, we must be able to get the lower limit and the upper limit. The lower limit in this case is 0, but what is the upper limit? Because that region goes as far as this point, so we need to get the coordinates of this point, at least the corresponding value of x at this point. So what do? So you need to recall that at the point of intersection, the two curves are equal. And in that case, we are basically saying that x is equals to, so at that point, y is equals to 1. Y is equals to y, they are equal at this point. But the first value of x, of y is x is equals to, the other one is 9x minus x squared. So if you collect the like terms, you can take this one to the other side. You're left with 9x minus x, that is 8x, minus x squared is equals to 0. So we can factor out x into 8 minus x is equals to 0. So we can get two values of x, that is x is equals to 0 and 8. So we have x is equals to 0, then pick the second part, 8 minus x is equals to 0. Then take x to the other side. So we're left with x is equals to 8. We have two values of x. The first one is 0, the other one is 8. So recall that point of intersection, they are equal. So you equate the two. That means you already have x is 0, and on the other side, x is equals to 8. So in this, at this point, x is 8. So having that, it's therefore possible to get this area. So let's start by getting the area under the curve up to this point. So we should get the entire area under the curve, but up to this point. So we start by integrating the equation of the curve because we want to get the area under the curve. So 9x minus x squared. So when you integrate 9x for the limits, so the lower limit is 0 and the upper limit is 8. So we'll replace 9 into 8 upper limit minus 8 squared. Sorry, before we replace, I have not even integrated. Sorry for that. We have 9 over 2x squared minus x cubed over 3 plus c. So for the limit, lower limit is 0, upper limit is 8. So we integrate, we replace. So 9 over 2 into 8 squared minus 8 over 3 over 8 plus c minus 9 over 2 into 0 squared minus 0 cubed over 3 plus c. So in the first part, we should get 9 over 2 into 8, we get so the first part, we get 117 and 1 over 3 minus 32 plus c. So here minus, this is going to be 0 definitely. Then minus plus becomes minus c. So when you simplify that, 117, 1 over 3, that is for the first part, minus 32, you get 88. Just a minute. That is not the case. When you solve the entire part, you get 117 and 1 over 3. So when you solve all this, get 117, 1 over 3. Plus c, this one is 0, so plus c minus 0 minus c. So the answer in that case is 117, 1 over 3. Please notice that this area that we have 117, 1 over 3 is the area under the curve. area under the curve, so the entire area. But you notice the question was the area bounded by the curve and the line, so we are looking for this area. So how do we get that area? One of the ways that we can get that area is now get the area under the line. You have the area under the curve. Now get the area under the line. So that is a straight line. You can still integrate. So integrate x with respect to x to get x squared over 2 plus c for the lower limit 0, upper limit 8. So we're going to have 8 squared over 2 plus c minus 0 squared over 2 plus c. And that is the answer will be 32. So the area under the curve is 117/3. The area under the line when you solve this is 32. So to get this area, we have the area, total area under the curve all the way mpaka kwa hiyo line. Then we have the area from this line to the other line, the x-axis. So to get this area, we take the total area minus the area from the line. So that is 117. 1/3 minus 32. You get 88.2/3 square units. That is how you get the area of that region. That is the area you get. That is how you get the area. Not 88 but 85. I found that 85/2/3. Yes, 117/2 is 85, not 88. Now the last part, which is the application. So application of integration in kinematics. The same thing we did in calculus, the differentiation we mean. We are going to consider application in kinematics. So remember what we did yesterday or in the previous session, SVA. So displacement to get velocity, differentiate. Velocity to get acceleration, differentiate. Now the reverse process. You will start with maybe acceleration. You must given acceleration to get velocity, I integrate. So this is differentiate. Given velocity to get displacement, integrate further. This is integrate. This one is differentiate. SVA, differentiate. AVS, you integrate. The reverse process. And the other important things that we did yesterday, where we talked about initial velocity, time is 0, maximum height, acceleration is 0, instantaneously at rest, velocity is 0, maximum velocity, again acceleration is 0, minimum velocity, acceleration is 0, return to original position, displacement is 0, and time at the beginning of the 5th second, at the beginning of the 5th, that one started at 4, so at the beginning of the 5th, t is 4, at the end of the 5th, t is 5. During the 5th, between 4 and 5, and we've seen how we are now applying that between 4 and 5. We shall see that in practice in case we have such an example. Now let us see a particle. So example 1, a particle moves in a straight line. In a straight line with a velocity of the velocity 4 minus 1. Four minus t meters per second. Find an expression of displacement find an expression of displacement S from this point given that S is equals to 4 when t is equals to 0. So we are saying we have a particle whose equation or velocity, expression of v, velocity is 4 minus t. And I have just said if you have velocity and you're told to find displacement, displacement is a reverse. Look, you are at this point v. Let me write it here, SVA. We are at this point v. We are given velocity. So if you have velocity here, velocity, whose equation is 4 minus t, to get s, we do the reverse process, that is integrate. So to get s, I integrate 4 minus t with respect to, we are getting s displacement, so it's with respect to s. And in that case, s will be, integrate 4, you get 4t, that's by now I am sure you already know, minus t squared over 2 plus c. But you're told, you're given that s is equals to 4 when t is 0. So you have s and t. So s is equals to 4, t is equals to 0. That way this should help us to get the value of c. So when you replace that, you get s4 is equals to t. So 4 into t is 0 plus 0 squared over 2 plus c. So we have, when you simplify that, you get 0. So we have 4 is equals to c. So c is 4. So we can now write s is equals to 4t minus t squared over 2 plus c, which is 4. And that way you found the expression of displacement given the velocity. We have the expression of displacement given velocity. And that is what we are expected to understand in that case. Let us look at another example. So we are told in our third example, a ball is thrown upwards with a velocity of 40 meters per second. So A, determine an expression for 1 velocity. Good. So determine an expression for the velocity. One thing that you need to understand in this case, that when you throw an object upwards, like we were doing yesterday in the demonstration, this object falls back. This object falls back due to the pull of gravity. And remember that from your knowledge in physics, that pull of gravity is basically called the acceleration due to gravity. Acceleration due to gravity. So if you're falling downwards, you're moving in the direction of the pull of gravity. But if you're moving upwards, you're moving in the opposite direction. Downwards is in the direction of the pull of gravity. Upwards is in the opposite direction. So opposite direction means, so if you're moving, and remember, the acceleration due to gravity in this case is in most cases given as 10, although the accurate value is 9.99, so 10. So acceleration due to gravity, 10. So if you're moving downwards, so if I drop an object, its acceleration is 10. If I throw an object upwards, it's moving against gravity, so its acceleration is negative 10. You drop an object, 10. You throw an object upwards, the acceleration is negative 10. So the acceleration of our object, which is thrown upwards, our acceleration is negative 10. Now, having acceleration, we can get velocity. We say S, V, A. You have acceleration, you want to get a velocity, so you integrate. So to get velocity, I'm going to integrate negative 10 with respect to t. So when you integrate negative 10, you get negative 10t plus c. And that gives us velocity. So velocity is equal to negative 10t plus c. But we are told the object was thrown upwards at a velocity of 40. I am simply saying that the object was released at a velocity of 40. Released at a velocity of 40. Remember, the released speed is called initial velocity. So the initial velocity is 40. So initial velocity is 40. But what do we know about initial velocity? We said yesterday, immediately you release an object, you are releasing it at a certain velocity, but the object has not taken any time. So you're releasing it at a certain velocity. The object has not taken any time. So initial velocity is 40, and at initial velocity, time is 0. Time is 0. So when v is equals to 40, which is the initial velocity, t is 0. Should that help us get the value of c? Yes. So v is 40. So I have 40 is equals to negative 10. T is 0 plus c. And in that case, c is equals to 40. Now you rewrite the equation. V is equals to negative 10t plus c, which is 40. And that is the expression of, or rather for velocity. That is the expression for velocity. And that is the most interesting part of that question. You need to understand this. Start with acceleration. You throw it upwards, you're simply finding the acceleration. Part B. Find the velocity and height after t is equals to 2. So for velocity, that is obvious because we already have the expression for velocity. So v is equals to 10 negative 10t plus 40. So v is equals to negative 10 t, which is 2, plus 40. So we have the answer as 20 meters per second. That is the velocity. But for this displacement, you must first integrate, because you have velocity. To get displacement, you integrate further. So integrate negative 10t plus 40 with respect, is it plus 40? Yes, with respect to t. So we get s is equals to 5 negative 5t squared, sorry, not over 2, plus 40t plus c. So in this case, after integrating, this is what we are getting. But notice that we have 3 unknowns, and we are looking for s when t is 2. But we cannot get that before we solve this, because we don't have the value of c. So we need to figure out what is the value of c. So to get the value of c, think about it in this line. That initially, when you released the object, immediately you release the object, it has not covered any distance. So immediately you release, it has not covered any distance, so the displacement is 0. So basically we are saying initially, immediately you release the object, s was 0, it had not covered any distance. Again, immediately you release, it has not taken any time, because that is immediately you release the object. T is equals to 0. So if s is 0, t is 0, so c is also 0. And in that case now, we can now rewrite s is equals to negative 5t squared plus 40t. So we are basically using this concept here, whereby we are saying initially s was 0, t was 0, c was also 0. And with that, you can now get the value of s. S is equals to negative 5, 0 squared plus 40 into 0. Not 0 but 2. Time. We don't find when t is 2. And that should be able to give us the accurate answer. And in that case, our answer, the displacement when t is 2 is 60 meters. So that is what we need to know in as far as that is concerned. We should be able to respond to that as such. So use this interpretation here, whereby we are saying initially displacement was 0, time was also 0, and that means c was also 0. Then we will rewrite the equation of the displacement, replace the values of t with 2, to give us an answer of 60, and with that, we should be able to answer that question accordingly. And with that, we have come to the end of the topic integration. So during the next session, we are going to cover area approximation, and we'll only cover 2 areas because we've already covered the area under a curve by integration. So we're only going to discuss 2 methods, and that will mark the end of that chapter also. So make sure you familiarize yourself with the process of differentiation and the reverse process, which is integration. You need to know integration is a reverse process. Differentiation, you multiply. Integration, you divide. Differentiation, you subtract. Integration, you add. And that is that. Until next time, you can go through as many questions as possible in the 2 topics, particularly using your solving problems. And I have attached the guide for those who don't have in the previous sessions video. So you can use that link to do as many questions as possible using that the guide. So we meet next time during the next lesson, which will be in another topic called area approximation.